All right, day 8, the addition rule. As discussed in earlier objectives, we may want to calculate the probability of 2 or more options being successful events. For example, in a bag of marbles, there are 5 red, 2 green, and 3 purple. 5 red, 2 green, 3 purple. Maybe the successful event is either picking a red or green. This language naturally leads us to want to add the 2 probabilities together. We succeed with either red or with green, so we add them and get the probability of 7/10. So what's the probability of red? 5 out of 10. What's the probability of green? 2 out of 10. If we add those together, 5 out of 10 plus 2 out of 10 equals 7 out of 10. Therefore, this seems to be a very simple relationship. A or B is just A, probability of A, plus the probability of B. But, alert, alert, alert. Be careful. While it seems to be the general formula, it is not. This works nicely here because these 2 events are mutually exclusive. Right? There was no overlap. Let's look again. Red, green, and purple. Separate. No overlap. There are no red-green swirls or red-purple swirls or green-purple swirls. Nothing. So, let's look at another example, and you'll see how this rule will not work and needs a bit of revision. A single 12-sided die is rolled. Event A is a factor of 6. B is even. So, set A. Factors of 6 would be 1, 2, 3, and 6. Set B is evens. 2, 4, 6, 8, 10, 12. Well, the probability, so it's being P, not an R, the probability of A is 1, 2, 3, 4 out of 12. And the probability of B, there again, go again with my R. Probability of B is 1, 2, 3, 4, 5, 6 out of 12. Not 10. Getting ahead of myself. Now, if I add those 2 together, I would get 10 out of 12. But that's not the right answer. The right answer is 8 out of 12. So, let's look at why our addition formula worked for the first case and not the second. In the second example, we had 2 probabilities. The intersection got counted twice. Came back to our two-way frequency tables when we did our OR, and we didn't want to double count one of the numbers, remember? So, for some reason, this did not print off on the page like it was supposed to. So, here we go. The probability of A is 4 out of 12, which includes the 2 and the 6. The probability of B was 6 out of 12, which includes the 2 and the 6. So this is showing why this part got counted twice. So remember I talked about in the previous video how you can also subtract out the doubles? Well, what's the probability of the middle? 2 out of 12. If we subtract 2 out of 12, what do we get to? 8 out of 12, which I already said was the correct answer. So we talked about the two-way table and not counting the double space, right? So in this one, remember, I talked about in the previous one that was not 38 out of 50 and 28 out of 50, which would have been 46. We had to take away the 20. I'm sorry, 66, which then took away the 20, which got us down to 46, which was our proper answer, because we did not want to count this twice. So we had two choices, I told you. We could just add up the greens, or add up the totals and subtract by one of the doubles. So, the way to do it is the 38 out of 50 plus the 28 out of 50 minus the 20 out of 50, right? That double, and that gave us 46 out of 50. Because remember, I talked about you cannot actually have 66 out of 50. That doesn't make sense. So to take this into account, we need to modify our addition rule. The probability of A or B is equal to, like we thought, A, probability of A, plus probability of B, which is great, but we have to minus the repeat, the probability of A and B. I kind of already hinted at that in the previous notes. So, this formula works for all cases. If the two events have an intersection, then its duplication will be canceled out. And if they are mutually exclusive, it's empty. And it applies to adding two probabilities together and subtracting nothing. So here are a few examples. Given a bag of marbles with 2 red, 4 green, and 1 blue. Well, once again, first off, 2 plus 4 plus 1 is 7. Always a good number to have. So the probability of a red or green. Well, again, there's no intersection. They're mutually exclusive. So it's really just 2 sevens plus 4 sevens equals 6 sevens. Since there's no intersection, since there is no A and B, it's really minus nothing. So that's our answer. Now, given a standard deck of cards, remember, 52 for that. Red. What is the chance of getting a red? Well, that's 26, half the deck, I have 52. Plus the face cards. How many face cards are there? 12, I have 52. Now, we need to take out what are the red and face cards. Well, if there's 12 face cards, that's red and black. Half of them are red, half of them are black. So we need to take out 6 out of 52. Because there's 6 doubles. There are 6 red face cards. The Jack of Hearts and Diamonds, the Queen of Hearts and Diamonds, and the King of Hearts and Diamonds. So when we do that, we get 32 out of 52. And that's all.